Question 1. Through careful analysis of airflow dynamics in pharmaceutical cleanrooms, it was discovered that room A consistently has lower particulate counts than identical room B, despite having similar HEPA filtration systems and HVAC equipment. Room B recently underwent duct maintenance, after which a minor but continuous increase in airborne particles was recorded. What is the most probable root cause for the elevated particulate levels in room B? A. Inadequate air exchange rate due to reduced fan speed setting post-maintenance. B. Dislodged duct insulation particles entering the airstream during ductwork maintenance. C. Temperature drift affecting the dew point and increasing relative humidity. D. Overcompensation by HEPA filters creating excessive positive pressure. Answer. Correct answer. B. Explanation. When maintenance is conducted on cleanroom ductwork, there is a risk that fibrous insulation or particulate debris becomes dislodged and enters the airstream. HEPA filters are effective at removing particulates, but if the debris originates downstream of the HEPA filtration or overwhelms its capacity temporarily, airborne particle counts will rise. This scenario aligns with ISO 14644 clean standards and GMP X1, which both stress the importance of cleanliness classification and minimizing airborne contamination. The other options, while plausible, would result in different airflow behavior or environmental shifts, not a direct particle count increase immediately after duct maintenance. Question 2. In a modern context of pharmaceutical-grade HVAC system control, which component plays a critical role in maintaining redundancy and alarm signaling for fail-safe operation in cleanrooms requiring uninterrupted environmental stability? A. Programmable logic controller (PLC). B. Variable frequency drive (VFD). C. Low voltage transformer. D. Current sensing relay. Answer. Correct answer. Explanation. A programmable logic controller is essential for executing precise programmable responses to environmental input, especially in pharmaceutical HVAC applications requiring 24/7 monitoring. It supports alarm logic, redundancy protocols, and interlocks tied to cleanroom stability. This aligns with FDA 21 CFR Part 11 and GAMP 5 Good Auto Manufacturing Practice guidelines, which require validated audit trail control logic in critical systems. FDS modulate motor speed, relays detect current draw, and transformers supply voltage. But only the PLC offers comprehensive logic, alarm, and control functions essential for regulatory compliance. Question 3. Demonstrated by repeated audit findings across multiple pharmaceutical facilities, which of the following is the most critical reason why GMP-compliant HVAC technicians are required to document every calibration and maintenance activity in regulated environments? A. To ensure staff accountability for all maintenance activities. B. To allow for optimized scheduling of preventative maintenance. C. To comply with regulatory audits and traceability requirements. D. To help reduce costs through root cause analysis of breakdowns. Answer. Correct answer. C. Explanation. Documentation is a regulatory requirement under FDA 21 CFR Part 210 and 211 and EGMP X11, which demand traceability, repeatability, and auditability of all actions affecting product quality. Unrecorded calibrations or repairs can invalidate cleanroom validation and compromise product integrity, while the choices, accountability, scheduling, cost control, are operational benefits. The driving factor is compliance with strict documentation rules that ensure the HVAC environment meets validated performance at all times. Question 4. When considering duct balancing in a pharmaceutical production facility, technician Maria is adjusting dampers in an air distribution system that services both ISO Class 7 and ISO Class 8 rooms. However, after adjustments, the ISO Class 7 room begins showing slight pressure reversals. What should Maria do next to maintain compliance with cleanroom pressure requirements? A. Increase supply airflow only to the ISO Class 7 room. B. Add additional exhaust to the ISO Class 8 room to lower back pressure. C. Rebalance airflow across the entire system to re-establish pressure cascade. D. Install backdraft dampers in return air ducts to prevent reversal. Answer. Correct answer. C. Explanation. ISO cleanroom pressure cascades are interdependent, especially when rooms of different classifications are served by shared duct systems. The correct approach is to rebalance the entire system, not just adjust one room. This ensures the differential pressure gradient, typically 515 pascals, is maintained. As per ISO 14644 and GMP Annex 1, pressure relationships are critical. Contamination control. Local fixes like increasing supply or adding exhaust can create new imbalances or turbulence elsewhere. Question 5. Given the circumstances of a new pharmaceutical HVAC installation, validation engineer Thomas observes that after performing installation qualification (IC) and operational qualification (OC), airflow velocities in a critical area fluctuate beyond acceptable tolerance levels. What should Thomas do next in accordance with validation protocols? A. Proceed to performance qualification (PQ) since IC and OC are complete. B. Modify commissioning documents to reflect new airflow specifications. C. Investigate the cause and re-perform OC after corrective actions. D. Submit a deviation report and continue operations under change control. Answer. Correct answer. C. Explanation. If OC results do not meet acceptance criteria, the system has not demonstrated consistent performance under operational conditions. The appropriate action is to investigate and correct, then re-perform OC. Moving to PQ or accepting deviations without resolution violates GAMP5 and ISO Baseline Guide Volume 5 Commissioning and Qualification. Change control applies only after validation is or planned changes are approved, not as a workaround for failed tests. Question 6. Throughout the course of HVAC servicing in pharmaceutical environments, which of the following instruments is most appropriate for verifying laminar airflow velocities during certification of ISO Class 5 clean benches? A. Digital anemometer with thermal probe. B. Pitot tube with inclined manometer. C. Ultrasonic leak detector. D. Differential pressure transducer. Answer. Correct answer. A. Explanation. A digital anemometer with a thermal hot wire probe provides precise low-velocity airflow measurements, which is critical for laminar flow benches requiring consistent airflow, typically 0.45 meters plus. 20% per ISO 14644-3. Pitot tubes are suited for higher velocities, while pressure transducers measure differential, not velocity, and ultrasonic detectors identify leaks, not flow uniformity. Certification requires repeatable and accurate data collection consistent with NEB and SETA standards for cleanroom performance testing. Question 7. To illustrate this point, technician OR is tasked with evaluating why the relative humidity inside the storage room housing hygroscopic pharmaceutical products remains consistently high despite the HVAC system's dehumidification coil functioning correctly, or physical principles most likely responsible. A. Radiation from nearby lighting raises dew point. B. Infiltration of moist outdoor air due to building pressurization imbalance. C. Excess convective heat transfer from supply diffusers. D. Re-evaporation from condenser fins due to coil cycling. Answer. Correct answer. B. Explanation. High indoor humidity often stems from uncontrolled infiltration, particularly in pharmaceutical facilities where pressurization is crucial. If negative pressure exists near exterior walls or loading bays, moist outside air enters, overwhelming the HVAC system's ability to dehumidify. This concept follows the second law of thermodynamics. Moisture migrates from areas of high to low pressure. ASHRAE 170 and ISO 14644 guidelines recommend positive pressure gradients and airtight envelopes to avoid this issue. Question 8. By evaluating the environmental specifications for a pharmaceutical packaging area, technician Kelvin notes that even brief temperature fluctuations are triggering process alarms. The set point is 20 UNDIC plus. 1 DIC with 50% plus, 5% RH. What should be the first action to ensure environmental stability without compromising product integrity? A. Calibrate sensors to verify accuracy before adjusting set points. B. Increase chiller capacity to account for peak loads. C. Lower RH set point to reduce latent heat in the air. D. Install reheat coils downstream of cooling coil. Answer. Correct answer. A. Explanation. Before making any mechanical or control changes, sensor calibration is essential, especially when dealing with tight tolerances like plus 1 deg. Sensor drift can lead to false alarms and misinterpreted data. Per ISO 9001 and FDA calibration SOPs, adjusting equipment capacity or RH without validating sensors could introduce new instability or violate validated environment conditions. Question 9. In light of recent developments regarding refrigerant management, which of the following actions must a certified HVACR technician always take when recovering refrigerants from a pharmaceutical facility chiller for maintenance? A. Vent non-condensables through a purge system before recovery. B. Reclaim refrigerant on site and reuse in the same system. C. Use HEPA-certified recovery equipment and document the process. D. Flush the system with nitrogen before refrigerant recovery. Answer. Correct answer. C. Explanation. Under HEPA, Section 608 of the Clean Air Act, technicians must use HEPA-certified recovery equipment and document refrigerant handling, especially in regulated industries like pharmaceuticals. Venting is illegal unless non-condensables are isolated and purged safely. Reclaiming for reuse must go through HEPA-certified reclaimers. Not on-site reuse unless standards are met. Nitrogen purge post-recovery for leak testing, not prerequisite for recovery. Question 10. With respect to advanced HVAC operations in pharmaceutical manufacturing, what is the primary advantage of integrating MS HVAC systems controlling cleanroom environments? A. Simplified user interface for junior technicians. B. Real-time monitoring, data logging, and alarm integration. C. Automated fan belt replacement scheduling. D. Elimination of the need for physical inspections. Answer. Correct answer. B. Explanation. A building management system, BMS, provides centralized control with real-time monitoring, historical data logging, and immediate alarm notifications, ensuring compliance with FDA 21 CFR Part 11 and GAMP 5. BMS integration helps maintain validated states, detect trends, and reduce response time to deviations, while simplifying UI or scheduling maintenance is helpful. Regulatory compliance and system reliability are the key reasons for BMS deployment in pharma HVAC systems. Question 11. When evaluating the merits of hydronic heating in pharmaceutical facilities, technician Marcus notices temperature instability in the HVAC loop serving a critical tablet compression suite. The facility uses a gas-fired boiler, modulating control valves, and secondary circulation pumps. Despite functioning components, room temperature readings show oscillation. What is the most probable root cause? A. Pump cavitation due to improper system pressure settings. B. Boiler short cycling caused by oversized heating capacity. C. Block strainer at the point of use terminal unit. D. Faulty boiler acostat calibration reading below design set point. Answer. Correct answer. B. Explanation. Boiler short cycling is a frequent issue in pharmaceutical HVAC systems with oversized heating capacities. It leads to repeated on-off operation, causing thermal lag and room temperature oscillation. This can undermine environmental stability required by GMP X1 and ISO 146444. While cavitation, blockages, or calibration issues could cause performance degradation, only cycling directly explains rapid oscillations under full operation. Question 12. To better understand filter selection in sterile manufacturing zones, technician Angela must decide whether to install HEPA or ULPA filters in an aseptic processing room ISO Class 5. Based on ISO and FDA requirements, which factor is most critical in choosing the appropriate filter class? A. Final cost of ownership including replacement cycles. B. Target particulate size to be captured at the filter. C. Facilities energy usage and airflow pressure drop. D. Material compatibility with the pharmaceutical process. Answer. Correct answer. B. Explanation. In ISO Class 5 environments, such as aseptic filling, filters must capture equals 99.99% of particles at 0.3 microns or smaller. ULPA filters offer higher efficiency than HEPA, but the selection depends on particle size and cleanliness class. ISO 14644-1 and FDA aseptic processing guidance emphasize filtration efficiency over cost or energy when sterility is at stake. Other factors may influence long-term planning, but particulate retention is paramount in sterile zones. Question 13. Focusing specifically on regulatory compliance, HVAC technician Daniel performs scheduled filter changes in an ISO Class 7 gowning room but forgets to record them in the Electronic Maintenance Management System (EMS). An audit 2 weeks later finds no documentation of this task. What is the most serious regulatory implication of this oversight? A. It may trigger increased preventive maintenance frequency. B. It could be interpreted as the maintenance was never performed. C. It might delay production schedule approvals. D. It could lead to questions about technician qualifications. Answer. Correct answer. B. Explanation. In GMP-regulated pharmaceutical environments, if it's not documented, it's considered not done. Per FDA 21 CFR Part 211.180 and Annex 11, documented evidence must exist to confirm compliance with preventive maintenance schedules. The absence of records undermines cleanroom validation and may invalidate batch records, causing severe regular repercussions, even if the work was actually done, or other choices are indirect or administrative consequences. Question 14. In what ways can chilled water systems improve environmental control in pharmaceutical manufacturing compared to standard DX systems, especially under varying load conditions? A. They provide faster temperature pull-down during startup. B. They offer better humidity control and higher part load efficiency. C. They eliminate the need for air handlers in each cleanroom. D. They reduce the complexity of integrating with building management systems. Answer. Correct answer. B. Explanation. Chilled water systems, especially those with variable flow and precision valves, offer superior humidity control and part load efficiency, critical for pharmaceutical spaces with dynamic loads. Per ASHRAE 170 and US humidity control ensures product stability and compliance. DX direct expansion units are less efficient under variable load and limited in their ability to tightly regulate heat. Air handlers and BMS compatibility are system design choices, not exclusive to chilled water. Question 15. During the process of validating a pressure cascade between 3 connected cleanrooms ISO 5, 7, and 8, technician Priya notes the pressure differential between the ISO 5 and ISO 7 rooms is only 1 par, while the standard is 1.015 par. No leaks or system failures are found. What is the most appropriate corrective action? A. Increase airflow to the ISO 5 room to re-establish the cascade. B. Seal all doors to reduce cross-room leakage. C. Conduct smoke testing to visualize airflow patterns and bypass paths. D. Reduce ISO 7 exhaust rate until pressures normalize. Answer. Correct answer. C. Explanation. Before making changes to airflow, it is critical to understand where pressure loss or bypass is occurring. Smoke testing is a diagnostic method supported by ISO 14644-3 and NEB protocols, helping visualize potential leakage paths such as door gaps or pass-throughs. Adjusting airflow without understanding the root cause can destabilize adjacent zones and violate GMP airflow direct requirements, especially for unidirectional flow in ISO 5 areas. Question 16. Taking into account a complaint from operations staff, technician Farrow is called to investigate increased deformation on process piping in a humidity control packaging area. She confirmed RH is within set point, but dew is visible on chilled water lines. All temperature sensors report within acceptable range. What is the most probable underlying issue? A. Piping insulation is degraded or missing at certain sections. B. Chilled water temperature has been raised to save energy. C. Humidity set points have been increased beyond spec. D. Pressure differential is driving moisture through walls. Answer. Correct answer. A. Explanation. Condensation occurs when pipe surface temperature drops below the dew point. Even if humidity and temperature are within range, degraded insulation can expose cold surfaces to ambient air, resulting in visible dew. This is a violation under Annex 1, which prohibits moisture accumulation in production areas. Sensor readings may not detect localized insulation failures. Pressure or energy-saving measures would not alone cause condensation unless insulation fails. Question 17. The primary reason for using a thermostatic expansion valve (TSV) instead of a capillary tube in a pharmaceutical-grade environmental chamber lies in which of the following operational differences? A. TSES can operate in reverse cycle for defrost functions. B. TSVS provide constant superheat control across load changes. C. TSES are easier to install and maintain. D. TSVS reduce electrical load on compressors. Answer. Correct answer. B. Explanation. ESVS maintain constant superheat, ensuring evaporator efficiency and preventing liquid slugging, especially under varying loads found in pharma chambers. Capillary tubes are fixed orifice devices that can adapt to load changes, risking inconsistent performance. Superheat control is critical for maintaining stable conditions per ASHRAE fundamentals and USB environmental chamber guidelines. Installation ease or electrical load reduction are minor compared to thermal control precision. Question 18. One might argue that pharmaceutical HVAC technicians face fewer risks than industrial HVAC workers. However, which of the following situations presents a critical safety risk specific to pharma environments? A. Climbing into ductwork to remove insulation. B. Handling HEPA filters containing viable biological contaminants. C. Using flammable refrigerants in rooftop chillers. D. Adjusting pressurized steam lines in heating systems. Answer. Correct answer. B. Explanation. HEPA filters in pharmaceutical environments can accumulate viable biocontaminants, including pathogens, especially in biological manufacturing zones. Changing or handling them requires PPE containment protocols and sometimes biohazard procedures as mandated by OSHA 1910.1030 Bloodborne Pathogens Standard and NIOSH Biosafety Guidelines, while steam and refrigerant hazardous biocontaminant exposure is a risk unique to pharma HVAC contexts. Question 19. Across different scenarios in pharmaceutical warehousing, technician Brian is considering replacing an older gas heater with a reverse cycle heat pump. What is the key consideration for ensuring year-round temperature stability in this application? A. The COP of the system during extreme summer conditions. B. Defrost cycles during winter, potentially interrupting heating. C. Compatibility with HEPA filter static pressure losses. D. Floor load capacity for new condenser units. Answer. Correct answer. B. Explanation. Heat pumps enter defrost mode during winter, temporarily reversing operation and interrupting heat delivery, which can be unacceptable in pharma spaces requiring tight environmental stability. G20 plus. 2. As per ASHRAE Applications Handbook, supplemental heat or defrost strategies must be in place to avoid excursions. Efficiency and compatibility matter, but interruption of heating is a major functional risk. Question 20. In response to a review of HVAC performance logs, facility engineer Jamal notices temperature drift at night in ISO class 7 prep rooms, even though no occupancy is detected and BMS indicates all systems nominal. What should Jamal investigate first to identify the root cause? A. Check for manual overrides in VAV terminal unit schedules. B. Review chiller capacity staging during unoccupied mode. C. Inspect for recent software updates to BMS logic. D. Verify time synchronization between environmental and occupancy logs. Answer. Correct answer. D. Explanation. Time desynchronization between occupancy logs and environmental controls can lead to false data interpretation. If systems are not correctly time-aligned, it may appear that conditions drift without cause. This violates FDA 21 CFR Part 11 requirements for accurate and auditable records in pharmaceutical environments. Before assuming control or hardware failure, data integrity must be verified. Software updates, chiller staging, and manual overrides are plausible, but log desync is often overlooked and critical. Question 21. The underlying principle of dew point control in pharmaceutical HVAC applications is critical in lyophilization and humidity-sensitive storage areas. Technician Eliza is monitoring a facility storing gelatin capsules and finds that the dew point remains constant despite small fluctuations in temperature and relative humidity. Which statement best explains why dew point is a more stable metric for moisture control? A. Dew point directly measures latent heat capacity in the air. B. Dew point reflects the moisture content independent of temperature. C. Dew point measures convective heat transfer in microenvironments. D. Dew point changes only when pressure and temperature both rise. Answer. Correct answer. B. Explanation. Dew point provides a direct representation of absolute moisture content, making it more stable than relative humidity, which fluctuates with temperature. ASHRAE Fundamentals identifies dew point as critical in pharmaceutical zones where condensation or microbial growth must be avoided. RH is temperature dependent. Dew point is not. Understanding this thermodynamic property is essential for consistent GMO-compliant climate control. Question 22. While examining a pharmaceutical HVAC systems control panel, technician Lionel finds an unexpected voltage drop across a normally open contactor coil. As a result, the air handler intermittently fails to engage during automated cycling. What is the most likely cause of this intermittent failure? A. Faulty overload relay tripping under light load. B. Loose neutral connection causing floating voltage. C. BMS control logic conflict in the programming sequence. D. Transformer winding resistance generating voltage lag. Answer. Correct answer. B. Explanation. A loose neutral connection can cause floating voltage across the contactor coil without completing the circuit, resulting in intermittent engagement. This electrical anomaly is difficult to detect but is a known failure mode in AC control circuits, as detailed in NFPA 17 NEC and IC 602041. The issue mimics sensor or logic errors but originates from poor grounding or continuity, not programming or load faults. Question 23. In contrast to analog gauges, what is the primary reason digital micromanometers are preferred for cleanroom pressure verification during pharmaceutical facility commissioning? A. They are less expensive and require no calibration. B. They eliminate the need for temperature correction. C. They allow data logging and higher sensitivity. D. They offer real-time leak detection with tracer gas. Answer. Correct answer. C. Explanation. Digital micromanometers provide precise pressure readings, plus 0.1 in HAR, which is essential for confirming pressure cascades in ISO-classified cleanrooms. They also log data for compliance with FDA 21 CFR Part 11 and ISO 14644 supporting audit trails. Analog devices lack sensitivity and do not offer digital traceability. Leak detection requires different equipment such as smoke or tracer gas systems. Question 24. From multiple perspectives in pharmaceutical design, what is the key functional benefit of terminal HEPA filter housings with gel seal frames over gasketed housings in Grade B sterile corridors? A. They are more resistant to vibration and noise. B. They reduce filter loading and increase lifespan. C. They ensure leak-proof integrity during pressure surges. D. They require less frequent airflow balancing. Answer. Correct answer. C. Explanation. Gel seal housings create a more reliable airtight seal compared to gasketed options, especially under pressure changes or thermal expansion, which are common in Grade B sterile zones. GMP X1 and ISO 14644 require certified HEPA integrity and leakage testing, and gel seal frames minimize bypass risk, ensuring contamination control. Other options relate to operational convenience, but leak-proof performance is the regulatory priority. Question 25. The evolution of pharmaceutical HVAC systems has emphasized predictive maintenance. Technician Sonia observes that a controlled exhaust fan shows irregular vibration patterns on the BMS, although airflow readings remain constant. What should she check first? A. Perform a thermal scan on the motor windings. B. Compare phase voltage balance on the VFD input. C. Inspect fan bearings and shaft alignment. D. Reset the fan's BMS vibration sensor calibration. Answer. Correct answer. C. Explanation. Unusual vibration patterns typically signal mechanical issues such as bearing wear or shaft misalignment, especially in VFD-controlled fans where harmonics and torque variations are common. Per ASHRAE maintenance guidelines and SRP best practices, these should be addressed before electrical or control systems, ignoring vibration risks, premature failure, imbalance, and non-compliance with cleanroom air stability requirements. Question 26. Given the circumstances of a facility upgrade, validation engineer Thomas is performing airflow visualization smoke testing in an ISO Class 7 cleanroom. He notices turbulent airflow around ceiling-mounted equipment even though airflow velocity and pressure are within spec. What is the most appropriate course of action? A. Increase room air changes per hour to reduce turbulence. B. Reorient HEPA filter positions to improve unidirectional flow. C. Install directional baffles near ceiling diffusers. D. Replace equipment with low-profile versions. Answer. Correct answer. B. Explanation. In ISO Class 7 cleanrooms, airflow visualization tests must show laminar or at least well-directed flow. If turbulence arises around equipment, HEPA filter orientation may be required to restore proper air movement patterns. This aligns with ISO 14644-3 and GMP NX1, which emphasize clean airflow paths over airflow volume alone, increasing iterate resolve to if airflow is not well directed. Question 27. When presented with data from a warehouse storing API active pharmaceutical ingredient drums, technician Diego sees that the relative humidity stays within 4060%, but product testing still shows degradation. What factor most likely contributes to the problem? A. Air mixing is insufficient, causing localizer H pockets. B. Humidity sensors are improperly calibrated. C. Dew point control is too aggressive. D. The product generates heat and alters local conditions. Answer. Correct answer. A. Explanation. In large spaces like pharma warehouses, poor air distribution leads to humidity stratification, resulting in localized zones that deviate from ambient RH. Even when average conditions appear compliant, pockets of higher RH can compromise moisture-sensitive EPIs. GMP storage guidelines, USB emphasize uniform environmental control, not just average values. Sensor accuracy or product heat may play a role, but inadequate mixing is the most common root cause. Question 20. Historically speaking, why are steam-based heating systems still widely used in pharmaceutical production HVAC despite higher installation and maintenance costs? A. Steam is less likely to promote microbial growth than hydronic loops. B. Steam systems are easier to integrate with BMS software. C. Steam minimizes heat loss over long distances. D. Steam allows precise humidity control in cold zones. Answer. Correct answer. A. Explanation. Steam systems operate at high temperatures, making them self-sanitizing, which is crucial in pharma where microbial growth must be strictly controlled (PGMP, NX1 and US), while hydronic loops can stagnate or develop biofilm. Steam provides sterile heat delivery. Other benefits may exist, but sanitation and compliance are the primary reasons steam is still favored in critical spaces. Question 29. To illustrate this point, technician Emina is troubleshooting poor room recovery times in an ISO Class 8 compounding room after door openings. She observes that air supply and return volumes match the design, but recovery remains slow. Which system adjustment is most likely needed? A. Increase filter replacement frequency. B. Raise air change rate above minimum ISO standards. C. Replace terminal diffusers with low turbulence units. D. Adjust door interlock timers to reduce disturbance. Answer. Correct answer. B. Explanation. ISO 14644 guidelines define minimum ET changes, but actual recovery performance often requires rates well above the minimum. In pharma compounding spaces, fast recovery to baseline particle levels is critical. Increasing it ensures faster particulate dilution and aligns with NEB performance testing protocols. Changing diffusers or interlocks helps but doesn't directly accelerate time like increased airflow does. Question 30. By comparing the use of HFCS and HFOS in pharmaceutical chillers, which of the following is a key advantage of HFO refrigerants that aligns with global environmental policy goals? A. Higher coefficient of performance COP under all loads. B. Compatibility with all existing oil lubricated compressors. C. Ultra-low global warming potential to be opposed. D. Complete immunity to temperature glide effects. Answer. Correct answer. See explanation. HVOS hydrofluorolefins are designed with the ultra-butypically one, making them highly favorable under Kigali Amendment and EPA SNAP Rule 23 for refrigerant selection. While they may have some temperature glide and may not be universally compatible with legacy oils, their environmental profile makes them ideal for future-proof pharmaceutical systems. This supports corporate sustainability, regulatory compliance in pharma operations,